Hi, and welcome back to AWS Julie. Today we're continuing our new series covering network fundamentals in AWS, and we will continue this series and dive into designing an Amazon VPC. I also added a few exam tips for the certification exams to this specific video. Let me know if I should continue to add exam tips throughout this series. Please remember to share this video with anyone who may be interested. Give it a thumbs up if you like it, sub if you love it, and let's dive in. So what is an Amazon VPC? Well, it is a virtual private cloud. So basically, it's your very own data center in the cloud. And AWS allows us to provision our own Amazon VPC in a logically isolated section of AWS. And we can launch different resources and create our own virtual private network. And we have complete control over this virtual networking environment. And that includes even choosing our own CIDR range. So our own IP address ranges, creating our own subnets, and configuring access with our route tables and NAT gateways. And you're going to see in a later video that you can create a public-facing subnet for your applications to have access to the internet, but also create private subnets with no internet access to secure your databases and your backend systems. And the Amazon VPC offers multiple different layers of securities. So we have network ACLs and security groups that we can configure to control who and what is allowed to access the resources inside our Amazon VPC. We can also create our own hardware virtual private network, so VPN connections, between your on-premises data center and your AWS VPC so that you can leverage AWS as an extension of your current environment or your current data center. And this is called a hybrid environment. We just said that we can launch subnets inside our Amazon VPC and choose the IP address range. And remember, from the shared responsibility model, we can create our internet gateways and attach them to our VPC. We can configure our route tables, and we can configure our NACLs and our security groups to have security control over the AWS resources inside the Amazon VPC. We also have two types of VPCs in AWS. We have a default VPC, which we're going to talk about, and a custom VPC, which we'll also talk about in another lesson. Your AWS account comes with the default VPC so that you can immediately start building in AWS, and you really don't need to know anything else. The default VPC comes with subnets, an internet gateway, route tables, security groups, NACLs, and all of this is already configured for you. But there are differences between the default VPC and custom VPCs that you need to know. So when you create a VPC, it is one region and in one AWS account, and this makes a VPC a regional service. And VPCs operate resiliently by operating in multiple availability zones in a specific AWS region. And by default, when you create a custom VPC, it is isolated and private until you explicitly grant public access. But there is one exception, and that is the default VPC. When your default VPC is created by AWS, when you create your AWS account, it is wide open. And you can only have one default VPC per region. It can be deleted and then recreated, and you can create a custom VPC that is configured specifically by you for your requirements as you need them. And we are responsible for all the configurations for the custom VPC. And remember, those are isolated and private by default. But default VPCs, like we said, are created by AWS when we create our AWS account, and AWS sets up this particular configuration for us. And each default VPC comes with one VPC CIDR range, which is a given range of IP addresses, and this VPC CIDR defines the start and end range of the IP addresses that this default VPC can use. So everything inside your VPC uses this CIDR. All communications, ingoing and outgoing, are going to be from and to this CIDR. And all default VPCs are configured in this exact same way. And with your VPC, you can divide your network across availability zones for resiliency. So we can subdivide your VPC into subnets located in each availability zone for that region. And each subnet in your default VPC uses part of the IP address range of the VPC CIDR. And each subnet's IP address range must be unique to the other subnet IP address ranges, and it also should not overlap. So if one of your availability zones fail, then that subnet in that failed availability zone will also fail. But with the default VPC, you will have other subnets in other availability zones that are still operating. And this default VPC CIDR is always the same, and it's designed and configured the same too, and that is 172.31.0.0/16. And AWS also adds a /20 for our subnets in each availability zone in that region. And subnets in your default VPC are assigned public IP version 4 addresses. So they're all public subnets, and each default VPC will be provided an internet gateway, security groups, NACLs, and you can see all of those in this diagram. We can also use IP version 6 for your Amazon VPCs. And the IP version 6 CIDR for your subnet range is a /64, and the IP version 6 CIDR range for your VPC is a /56. And communication inside your VPC is going to use the local routes. And it is important to remember that the default VPC CIDR is always the same, and the default VPC in AWS is always designed and configured the same too. And in our OSI model lessons, we talked about how data flowed through our network. So let's dive deeper into the Internet Protocol. So far, we've learned that IP, the Internet Protocol, is how devices communicate in AWS and over the Internet. And there are two Internet protocols, IP version 4 and IP version 6. IP version 4 addresses are represented by the dotted decimal notation, which consists of 4 numbers from 0 to 255, separated by a period, and the bit between the period is called an octet. So it starts with 0.0.0.0 and ends with 255.255.255.255. And this gives us over 4.2 billion IP addresses. And this is a large range of addresses, but we're running out of IP addresses because these days people have laptops, mobile phones, tablets, they have refrigerators. So this range of IP addresses was split into classful addressing into smaller ranges. So the first range is a Class A, and it gives us over 2.1 billion IP addresses. The Class B gives us a little over 1 billion IP addresses. Class C's give us a little over 2 million IP addresses, and we also have classes D and E with IP address ranges too, but AWS doesn't really use those. Most people don't really use those. And these IP addresses that you see here on the screen are publicly routed IP addresses that we can connect to. But we also have private IP version 4 addresses, and there were also ranges created for the private networks to be used in AWS, and these IP addresses cannot communicate over the internet because they're private. And these IP version 4 private addresses were also broken into classes that you see here. And our default VPC in AWS is configured with a Class B. So for private IP addresses to communicate with the internet, they're going to have to use NAT, which is Network Address Translation, and we'll be covering that in a later lesson. So this classful process for IP version 4 private and public addresses was eventually replaced with CIDR. And CIDR stands for Classless Interdomain Routing. And CIDR removes the limitations of being limited to a Class A, B, or C size networks. And CIDR addresses are represented by the starting IP address of the network called the network address, and the prefix, which is a / and a number, represents the size of that network. So a CIDR looks like this, 10.0.0.0/16. And for your certification exams, especially for the associate level, you don't need a high level understanding of networking, but I'll add some links in case you do want to take a deeper dive. But understanding how CIDR works, how subnetting works, especially for the more advanced networking certifications, but in the real world is going to make a huge difference. So for your exams, try to remember that the bigger the prefix, the smaller the network, and the smaller the prefix, the larger the network. So back to our 10.0.0.04/16, this is going to provide us a total of 65,536 IP addresses. And with CIDR, we can split up this IP address to create different networks. So we could split it up into 2 networks, which would be 2 /17s, or 4 networks, which would be 4 /18s. And this process is called subnetting. We take the network and we split it up, which increases our prefix, creating 2 or 4 smaller networks. And each time we split our network, our prefix gets larger. Because remember, the larger the prefix, the smaller the network. Let's also talk about 0.0.0.0. This means all IP addresses, and this is the biggest of all the networks. And for your certification exams, you may also see a /32. And a /32 means one IP address. And this is the smallest network possible. A /8 is going to give us 16 million IP addresses, and this is a class A. /16 gives us 65,536 IP addresses. It's a class B. And a /24 gives us 256 IP addresses, and it is considered a class C. So let's also talk about IP version 6 in AWS. And an IP version 6 address is much longer, and it's represented in a hexadecimal rather than the dotted decimal like IP version 4 addresses. And this is 128 bits long, and it's called a hex tech because the address is so long, we can abbreviate the address by removing redundant zeros with 2 colons. And the networks are also represented using the start address and a prefix. But with IP version 6, each hex text is 16 bits, and that prefix number is actually the number of bits that represent the network part for the IP version 6 address. And in AWS, you cannot choose your own IP version 6 address. It is assigned when you create your VPC and decide to use IP version 6. The IP version 6 CIDR for your subnet, again, is a /64, and the IP version 6 CIDR range is a /56. And remember that a double colon represents unneeded zeros, so ::/0 is going to mean all IP addresses, and you may see this on your certification exams too. Now in the next video, we're going to dive a little bit deeper into networking on AWS, and we're going to dive into subnetting and start building our own custom VPC. Thanks so much for stopping by, and I hope to see y'all again real soon.